lecture of Algebra 1, the first lecture in Algebra Analysis 1. Before we get to the lecture, I would like to introduce myself. My name is Rania. Boulahia. I have a master's degree in mathematics. Our lecture topic is logic sets, relation, and maps. We already talked about logic sets, relation. Now we are talking. We also advanced in maps. We talked about what is the definition of a map. We talked also about everything, injection, surjective. We talked also about the graph of a map, where we defined the injection, what does the injection maps means, and we said that we take the couple x1, x2, f of x1 equals f of x2, that implies that x1 equals x2. And now what is the bijection? A surjective and bijection. A surjective is when you take a value y from f, which is the map f e into f. If we take y from f, there exists an x in e, such that y equals f of x. And a map surjective if for all y in f there exists a unique x that y equals f of x. It's simple. Map combination in maps. If we combine map with the identity map, we get the same map. We combine three maps, so we can just the parentheses. For example, if we map G with the couple G or row F, this relation, we read it row, composite map. If we change the parentheses, inverse map. Every map has an inverse map if it is bijective. If it is both surjective and injective, then it has an inverse map. A map f that takes value from e to f is a bijective. Then there exists a unique map denoted f1 or f to the power f minus 1 from e to f, from f to e, of the inverse map of f that maps y from f to an element x in E, such that y equals f of x, and we have, if we take the couple xy, where y is in f and x is in E, y equals f of x, that's equivalent to that x is f1 y. That map satisfies combine the two maps, the inverse map and the map, and then we get the identity map. Change the order, like f1 row f is equals to f row f1 and equals the identity map. Remark on finding the inverse map. Suppose that f takes value from e to f is a bijective. If we find a map that takes value from f to e, such that g row f equals the identity, or f row g equals the identity, then we necessarily have g equals f1. I'm saying f1 because I take the lectures, all the courses in the university in French, but if we can say f to the power of minus 1 or f minus 1. Let F takes value from E to F and G takes the value F be two maps. If F and G are injective, then G rho F is injective. If F and G are surjective, then G rho F is surjective. If F and G are bijective, then G rho F is a bijective. And we have the inverse map of the combination of G rho F is F moins A rho G moins A. Image and definition. What is an image? An image of and under F denote F of A is the F of A where A is a part of E. If we take the image of a part of A, which it will equals F of X for all X in A in the whole space F. The pre-image or the inverse image, pre-image or pre-image is the inverse image of B under F. We denote it by F moins A of B, and it is F moins A of B equals to all the x's in E, where F of X is in B, and it is included on E. Caution: when we write in F moins A of B, it doesn't mean that the map F moins A exists. This is an example. This is a simple example where we take F of X is X squared. So it is not injective and not surjective. Not injective, why? Because 1 and minus 1s both map. Not surjective because minus 1 surjective because minus 1 has no pre-image, so F moins A of minus 1 doesn't have an image. And if you take F of X, we changed here the starting space with R1, F of X equals X squared. It is injective but not surjective, because injective but not surjective by the definition. Why not surjective? Because minus 1 has no pre-image. If we change the space that F takes for value from R into R plus, F of X equals X squared is surjective but not injective, because 1 and minus 1 have both maps to 1. But if we take if F takes the value of from R plus into R plus, F of X equals X squared, it is bijective because its inverse is because it was injective and surjective. There is no points where 2 equals X implies that F of X equals F of X1 X equals F of X2. It is surjective because it is on 2 and 1 1. We will talk about the mathematical proof, how we prove a statement or a proposition. There is a direct proof where to confirm that Q is true, we use the proposition already known to be true. If P is true, then P implies Q is true, then Q is true. And to prove P implies Q, we assume P and we show Q.